Welcome back. We continue broadcasting here from Xilexpo Arena 2022. So we're going to talk about a strong topic, engaging topic, and it's quite future-oriented because at long last it's going to put an end to the old dispute arising when you buy machinery produced from different companies, different brands, and then you have to use consultants, developers, programmers in order to have these machines talk to each other. So in the future we will be able to do this, not just because they will be working well together, but because they will be working well together, obtaining the best of results. So there's been, I think it was 2015 when I first heard of this topic. Then the thing actually evolved across Europe. Different companies were involved. The Seven Sisters, as I call them, joking a bit, but it's really the seven companies or seven big competitors that do pave the way, and we're talking about Biesse, Bürkle, Homag, Ima Schelling, SCM, Weber and Weinig. And they're involved in this project. All seven sisters are involved so that their own machines will be able to talk to one another perfectly, seamlessly. And all the other companies are going to follow through because this is the future, really. And today we have two people here that are directly involved in this project, and they're going to give us an update of what is happening. You have here Luca Fariselli, the Corporate Communications Director, a part of the marketing team of Woodworking Made Easy. Easy is very catchy as a word, written as it is, IZY. Can you give us a picture, an overview of what Woodworking Made Easy is all about? Well, thank you. Morning, everybody, to everybody who's here and connected remotely. It's a challenge. It's definitely a challenge because when we started with this project, and I would define ourselves as the seven cousins rather than seven sisters, but it's okay anyways. But if we had thought, even just 4 or 5 years ago, that we would have ended up being seven competitors sitting around the same table, collaborating, working together to find a solution for our clients, for our customers, I think that nobody would have bet even just €1 on this. So it was a bet. And I started working in the marketing team right after the development, the setup of the technical group, working group. Next year it's going to be 4 years. Well, and in these almost 4 years, we try to think in the client's perspective. So from the client's standpoint, and the problem that we are faced with, or that clients are faced with when buying our machines or buying machines from our competitors, is that, of course, every manufacturer develops their own software programs. So it's proprietary software or third-party software, but still adapted to their own technologies. So when you have different technologies coming from different machinery manufacturers, then of course the client is met with difficulties because they have to integrate all these technologies with those of other, or with the help of external partners or technical interventions, requiring a lot of time and a lot of investments, financial investments. Therefore, for us, the solution was to find a standard interface allowing a manufacturing execution system to different machines, different brands, immediately and in a simple way. And the only way was to develop a unique protocol, a protocol that would work for everybody. And so that's where we decided to adopt the OPC UA protocol. It's a standard protocol, encrypted protocol, secure protocol, already used in other industries as well. And that's how we were able to create a working group that developed in these last few years a system that had quite a huge impact on our organization and software development. But to get to software solutions that already today allow our clients to integrate their machines using MES, an MES system, in a much easier and much more immediate manner. Going back to the Seven Sisters, we were sitting around this table. Initially it was the engineers who worked hard in order to be able to get to an agreement, because think about the Seven Sisters, 7 leaders in the industry, each one of them having their own system. So it's not something given for granted. Each one of us had to give up something to achieve a greater common goal, the end purpose, and our end purpose is our client, our customer. We always talk about, we hear a lot of talk about customer care, but it's oftentimes empty words. I think that here in the woodworking industry, at least these 7 companies, but not only them, do care a lot about their customers. So this has to be perceived by customers as well as a sign going into this direction. And of course, us as companies alone wouldn't have been able to do much without the help and support of stakeholders supporting our work and supporting us in working together. So I'm talking about national, Italian and European associations like ASIMAL, VDMA, UMABA, that really puts together all European associations. They really facilitated us, collaborated with us, and coordinated, if you want, our work, what we were trying to achieve, including meetings amongst teams, reaching an agreement. At the end, we also involve UMATI, which is the community that already in the steel industry has started a few years ago to develop this standardization platform, still using the OPC-UA protocol. And this somehow reassures us, because we know that materials is not just wood, and the companies producing and supplying our companies, they may also have different machinery for working different materials, different technology, robots. So this somehow also helped us. That UMATI was actually like a facilitator to make sure that we're able to funnel into one single platform all of our data. Of course, now we have reached a stage where we have not we're not done with the work yet. Then my colleague is going to tell you more, but we've already reached our first step, which is the goal we had set ourselves, and our target was to be able, first of all, to provide the standardized data to the MES, any MES. So, standard or OPC-UA data. And the greatest benefits will go to small to medium-sized companies, because of course this protocol will be useful for everybody, even large industries, large-size manufacturers, but they do have a lot more resources than smaller-sized companies when they need to integrate the different machineries. So everybody will benefit from this work, but mostly small to medium-sized enterprises or companies. So a couple of words about the concept of IZY. We draw inspiration from standard universal languages, like for instance the Morse code or the Braille alphabet for the blind. And from these concepts we somehow gave birth to an easy name, a name that can be pronounced in English the same way as it is pronounced in Italian or other languages, that can and a name that can convey this idea of simplicity, easiness. It may seem somehow trivial. That's what I thought at the very beginning, but it does really express what it means. And we can, we can talk about it with our stakeholders. And when I talked about OPC-UA, I talked about an open protocol. It's an international standard. It's not European, it's international, and it's open to other manufacturers that one day will want to join us in this effort. We've already received a few requests from some non-European companies, but of course you can't do it in 2 minutes. First of all, because we are still completing our technical process, and on the other hand, we want to assure our clients that whoever is going to adopt the EASY system is going to be, the system is going to be certified. So when there will be other companies that will be joining this project, the standards will be assured, the software standards, so that so we are certain that this is not it's not just going to be like a certification that you get, I'm also easy, so that everybody thinks, well, no, we're going to make sure that everything, the data are going to be developed correctly. I talked about benefits for companies already, and we've also added the fact that an average 10% increase in productivity, but we've been on the safe side with our estimates. It's probably going to be more than 10% increase in productivity. We'll see in time. Nothing is engraved in stone here. So when we're going to move on to step 2, so having machine talk to machine, the productivity of a more integrated process will be even greater. But of course this, it seems to go against the interests of individual manufacturers. So every client is free to buy the machine they want to buy. But we know it's not just an issue of technology. It's not that, it's the whole set of things, after-sales service, competency, and then including loyalty, because the client becomes loyal over time when they have no problems. But if you want to buy Homag, ICM, I mean, you can buy anything, Biesse, Homag, Bürkle, I mean, you can buy from anybody. We do believe that, strongly believe that this is the right approach to continue working in the best way. I'm going to close this part, this introduction. I'm going to leave the floor to my colleague, and he's going to give some more technical details to understand better what it's all about. But here, for instance, we have the innovation manager of this company, famous worldwide known Swiss company, Baum Informatique, Mr. Fern. At one point he said, establish data exchange with reduced costs in a flexible way is very much needed for the industry, particularly for small, medium-sized companies. Basically what I told you earlier, and this is and he said this before our project was started. So I would like to thank you all. I'm going to leave the floor to give the floor back to Luca for the second part.
Thank you, Gianluca. Now the framework is much clearer. The scenario is becoming really interesting because the first phase with the MES is one step, and the second step will be connecting or getting machine-to-machine to communicate with one another. So we have further aspects to dive into. We have Antonio Latella, which he is highly qualified. He's been in IZY group, and he's the technical digital service and IoT manager. I apologize for our foreigner guests. I'd like some of you to tell me in Italian what this definition, this qualification means. And we also have an engineer from IZY, who is the first group that started to work on this project. This project, let me repeat, allows the woodworking industry to make a further step forward and get closer to technological world that is not just as old as ours, but just like the industrial mechanics that has been dealing with this topic for more than 100 years. Well, after my presentation, I'm sure that you will fully understand what digital service actually means and what I do for a job and what my qualification means. So let's go back to our project. As already told, the core of the project is finding a common language that will make it easy for different machines to talk to one another, to establish a dialogue with one another, and also to talk with other software, such as an MES or other company or business management software, regardless of the technology. So we'll be able to connect cuttings, machining centers with MES, possibly. So basically, this will be possible through the same easy process that we use today to connect a laptop or a computer to a printer. Profiling machine Weinig could be connected to a machining center or a machine by Bürkle. So the basic concept is being able to connect a printer with any computer, or connecting a machine type with any other machine type, regardless of the underlying technology. I will now dwell on some more technical aspects of IZY. In order to do so, we necessarily have to dive into the target pursued by IZY, and we have to start thinking about cloud technologies. So how does the target client nowadays connect to the cloud? To perform data analysis, real-time monitoring, and possibly in the future he would like to perform more complex activities like KPI analysis of their machines. So on the cloud platform, in this case on a universal platform. So target IZY. Gianluca already anticipated is easy target are the small and medium-sized enterprises who are active in woodworking processes, and could be an edge bending center or a splicing machine, sanding machines. And these machines are now assisted by automatic loading or offloading systems, for example, picking system or a robot. And they may be connected to an MES. And in order to add some more complexity, all this will be connected to a cloud platform. So this is an overall generalization. So we have an hypothetical factory system of our target customer. Well, at this point, it is important to understand that the as-is of technology can be very varied. And this slide is a simplification. This slide identifies the various nodes of an hypothetical customer, and all the nodes of this network are interconnected. Given the nature of these devices, given the different nature of these devices, we have machines, software, picking systems. Well, all the internet connection nodes may be of different types. Each different device will use different standards or different protocols to get interconnected with all the other devices. So this web intensifies and is rich in a number of protocols and standards to be combined. Some of these standards and protocols are industrial ones. Some others, in some other instances, they are custom-made protocols. Oftentimes, you would use a data adapter to combine these devices. And these adapters can be devices or hardware pieces. And this adds on to the complexity of our network. They may as well be software patches that run in the various computers, and they decode the data, and they adjust the data to make it compatible from one device to the other. So why is it necessary to give this overview? Well, basically to get a full understanding of our customer or our target customers, and let's try to get an understanding the role of each and every node in the network, in the web. There is a standard that tries to do that. There is a standard that tries to set an order in the web nodes of our hypothetical factory system. The standard I'm referring to is ANSI ISA 95. It's most commonly known as ISA 95. It's an international standard. It's been released by the International Society of Automation, and basically this standard tries to classify the nodes that we've seen depicted in the previous slide, and it classifies them in a hierarchy. It's an extremely generic standard. It can be applied to any type of process, batch processes, repetitive processes, continuous processes. In our case, we will simply use this ISA 95 standard to model our factory network. Let's just give a brief look at it. Let's start from the left, level 0. That's the field level, the machine level. So we are at the machine side. And here we have manufacturing processes, we have sensors, we have signals, actuators. And then we have level 1, that's the PLC, sensing and manipulation, machine rational, machine logic. We are still on the lower part of the scale. And then we get to level 2, that's monitoring and supervision. It could be SCADA, HMI system inline or for the entire plant. So this is the entire field part, field network. We're still in the workshop. We're still in the manufacturing workshop. In order to get to the IP side of the matter, the network side of the network, we then have to cope with level 3, MES, and then level 4, that's business planning, logistics, and that's where ERP or PLM systems come into the scene. Where is the cloud in all of this? We can imagine the cloud as a level 5, right after level 4. However, I always like to think of the cloud as of a liquid platform surrounding the entire scheme. It embraces all the other levels. It's interesting to look at the bottom scale, the data availability. On the field networks, we have a real-time data control, so it's a matter of milliseconds to have data. And as we go upwards towards level 4, data availability can be extended to days or even months. That's an interesting piece of data, the piece of information. So why this general overview on our manufacturing system? Well, this overview helps us understand why IZY works and why we have OPC UA as a choice. The gray blocks here represent the hierarchy identified by IZY 95. We have sensors, controllers on that was level 0, and then we also have a CRM ERP level 4. That's basically, these are pieces of the various layers that IZY 95 has identified. Using OPC UA to interconnect these nodes, the various elements of our hierarchy, leads us to the condition whereby the hierarchy is compressed onto one single level, and it can be represented horizontally. So I'll give you an example to make it clearer. In this network, an CRM ERP could hypothetically be knowledgeable about the status of a sensor on a machine. So it could be knowledgeable about the status of level 0, a controller, with one protocol. So that only one protocol is enough to cross all the steps that we had earlier in the previous slide. And this is a very powerful strength of OPC UA. And this is one of the main reasons why the OPC UA approach is taking roots and in factories and in the manufacturing world. So an ERP system is able to detect the status of a sensor. The cloud system also is implemented through OPC UA approach. We have a cloud, a software module that aggregates data. The data that I receive from a sensor or from an HMI system can be different, very different from one another. So it is necessary to have a first data aggregation level in order to put them on the cloud. So that first block will do the first data aggregation. IZY is a universal platform, so we think it attached to our cloud. So how can I connect a machine to a universal platform like IZY? Let's look at this step. So interconnecting or connecting to the cloud, connecting several machines to the cloud implies having a local part and a field part. That's the physical machine, the manufacturing system. And you then need to equip yourself with an OPC UA server, which is IZY compliant and compatible with a data structure that shares the same common language, and also VPN client. The VPN client allows to connect the machine to a VPN endpoint. The endpoint is essentially basically a VPN, a container, a group, and you can do this through a tunnel. So the machine data flows through the VPN tunnel to the VPN. And the VPN is one of the universal machines. It's a cute concept. So we have a VPN of universal machines. This means that all easy connected or easy compliant machines are also connected to the VPN. They send their data to the VPN. So it's a container of universal machines, machines that are scattered throughout the world. And please be careful of safety and security. The connection to VPN is not an open-ended process. You need to have a certificate to connect to the VPN. The certificate is released upon completion of an onboarding procedure. In order to see my machine on the universal platform, I first have to complete the onboarding. I have to register in the platform. Upon completion of this process, a certificate is released. The certificate is downloaded, and you use the certificate to connect your machine to the VPN. So there is security in the system. This is as far as the field networks is concerned. Let's look at the remote parts of the process. It could be hybrid, could be partially in the factory, or partially or wholly in the cloud. So the platform makes us a first OPCUA client, which aggregates data. Please bear in mind that the VPN receives data from all machines worldwide, machines whose nature can be very, very different. There could be a robot, a picking system, a woodworking machine, a metalworking machine. Any type of machine can be in that, can be sending data. So it's necessary to aggregate data at a first level. So the OPC client is the first level of data aggregation, and from that client, OPCUA, data is then sent to an intelligence data hub. Basically, this is an infrastructure which has been developed by T-System, by Deutsche Telekom, and basically this platform makes data usable by the universal platform. So it's something between the VPN and the universal platform. One important thing to say has to do with security. The architecture of this intelligence data hub is the same architecture of the data hub made by the International Space Association. So there are extreme secure levels. Data flows from the data hub to the universal platform, where they can be used and taken by the client. So this is the complete chain. Can I ask you a question now? Of course. So when you talk about security, is it security shared amongst all the contributors to this virtual network, or also security towards whoever would like to break the wall of the network? So is it security shared amongst the registered accounts, or somebody from the outside too? So it's a security towards in both senses. So, as I mentioned, there is a security certificate connecting to a VPN by means of a certificate. Means that whoever wants to steal data is not allowed to penetrate the VPN, or maybe furniture suppliers, manufacturer that needs to access this data. let's call this entity, well, this entity needs to be registered with the platform. It needs to be identified by the platform. I am this account. Am I allowed to access data? So if you are registered and accounted for, then of course you have access. Second aspect is an internal security. Is the internal security of the VPN. My machine is not visible to other connected machines. So it's not a point-to-point connection. It's not a peer-to-peer network. It's not a client-to-client network. This is a network where we have many different clients, but each client only knows the endpoint, which is basically the concept of the VPN technology. Hopefully, I gave you an answer. Of course you did. Thank you. So we've seen how the data flow works from the machine to the remote platform. And how do I then interface with IZY? How does my machine interface with IZY? So a local, remote side. Let's go back to our previous diagram. And let me just share something short with you. The OPC server is preferentially connected to the HMI monitoring supervisory. So the second level of ISA 95, as we saw earlier. Basically, it's a PC, whether it's a plant-related PC or a inline PC, it's a PC. In order to implement an OPC UA server, we have anything. We have C++, .NET, the entire Microsoft range is there. So if I have a PC, a Microsoft PC, a Windows PC, I can integrate a server, an OPC UA server with whatever technology. Python and Java are also being introduced, and also OJS. This allows us to have a cross-platform, so I don't even need a Windows PC. I may just have an embedded PC card. So these boxes, these card boxes, that are able to accomplish everything. And it's using Python, Java. Non-platform languages, JS. The left side of the slide is just a description to show that OPC UA is really penetrating the factory system very strongly. We see Schneider Electric, Beckhoff, Siemens, KUKA. They already make OPC UA server available on the PLC side. So we're still at the field level here, so at the place of the end user. What we saw earlier, the web that we were looking at earlier, which is then compressed to one level only, is not just an utopia. The technology to deliver that is already available. I also listed KUKA. KUKA is approaching the robot-sized supervisory system and also automatic picking systems. They can interconnect with the workshop, with the factory, and therefore head towards the universal platform through IZY. Hopefully, I was able to clarify a little bit the technical aspects. Well, to me it was kind of difficult to, quite a struggle to follow you. You use big words, technical terms, but I understand that this is a window open on the future. This is something that is going to be revolutionary. My concern, if not curiosity, is this. How can we get from the chair manufacturer from down there, San Giovanni Lattosone, to the table manufacturer? How can these European machinery that is an excellent level of performance. Otherwise, we wouldn't be here. Otherwise, these seven sisters wouldn't even be here. So how can this excellence from a machine point of view be shared as an asset internationally or even universally? But will we be able to involve even the smallest manufacturer, or will this revolution just address one part of the world, and the world will be divided between the good ones or the not so good ones, even in the furniture industry?
Okay, can answer the question from my standpoint. It's an issue of I can carry on business as usual, so nothing changes for a furniture manufacturer that decides to buy a machine that does not use this standard language, or another furniture manufacturer may decide to buy it. But if you don't buy a machine that uses this language, you will have to pay somebody to communicate with other machines, or you may be more forward-looking. And actually, we're talking about the most important, the leaders in the market. So if they are doing this, so that means that this is the future. I believe it's an issue of time. So over time, for sure, people, companies will understand that we're going to save time, resources, and they will be working in a much leaner way. They will have access to the production data. I don't see is it a problem for the future. I mean, there will still be somebody who has their own old machines, and we will have to still try and integrate the different machines in a different way. But I think it's going to be an issue of time, not much time really. So time to digest this new opportunity. Antonio, we were talking about the certificate earlier. So whoever wants to join this family must pass a test, a competency test, a security test. What does this sort of registration, who does it? Who sells the machine? Who uses the machine? Technical detail that I would like to add to your first question. The standard is a standard, but it's also a release candidate. We are now standardizing. Well, right now the platform makes it possible to use essential data of the machines, so the manufacturer's side, so machine identification data, besides details about worker groups, axes. So this is to say that right now we are in the phase of the release candidate phase 1.0, so we only have a portion of all the data sets of an individual machine. As you know, an individual machinery does have millions of data. Over time, we're going to process higher level data, like introductory data. So to go back to your question, yes, will happen, and it will happen in time, as just Luca said. Once we achieve a standard with a complete set of data, that's when we will be able to fully integrate all the data yielded by the machine onto a universal platform. Now, to answer your second question, the registration, the census, the onboarding onto the platform can be done by both sides. I, as a manufacturer of a woodworking machine, I can sense my machine pre-sales, so I can sell you an easy compliant, already connected, platform connected machine. But if you already have machineries in your factory, you can do the onboarding yourself as a customer. So both sides can do it. So the important thing here is to get on board, to get onto the system, be recognized, and to have access to information. Exactly. And by the way, onboarding in terms of user experience and user and UI can be as easy as possible. I mean, you can tell a client, go and connect your terminal unit using this, go there. No, the onboarding process right now has been structured in a very simple, very easy way. You don't need any special technical competencies to get your machine on board the platform. Of course, you need competencies in order to integrate locally. So this slide, you have to integrate the OPC server onto the machine. It's not even so technical, but still. But once we've defined the dictionary, then it's going to be relatively easy. Of course, if anybody here from the room has any questions, please go ahead. Please. One last thought. Over the last few years, everybody, the leaders and also smaller companies, in the last, I would say, 15 years, have been really pushing towards having machines, system integration, MES integration, proprietary systems, the one from Germany, the one from Rimini, the one from Rome, and so everybody created their own word, so to speak. So this was the prerequisite. If we hadn't done this, we could not have thought about ending up developing UPC OA, or have we made the work done in the past 15 years obsolete? No, we have actually supported the work done in the last 15 years. After all, OPC UA is a software interface. Any software program, I mean, MES or any other software program should simply implement an OPC UA interface. So you keep your software, you add an interface that talks another language, that speaks a different dialect. MES right now talks to the machine on a specific network interface. Now, we're going to add an interface which is OPC UA. I'm not throwing away MES, I'm just adding an interface so that the MES, the system that I've developed for 10 years, it's like a simultaneous interpreter, like a lady sitting in the booth. It's a bit like, it's the reason for OPCUA to exist. And I'm going back to big words and apologize. It's it's a data interoperability standard across different devices. So we have a number of devices, each one talking their own language, their own dialect, and the OPCUA was born, I mean, even prior to IZY, our IZY project, OPCUA was developed to cope with this need, actually, to tackle this issue. We have a number of very different devices, but they can interface, they can interact. And I would add that, of course, these devices must share the same dictionary. If I talk to you, I need to know what language you're talking and what you're telling me actually means. So, if a CRM or ERP talks to a machine sensor, they need to know what language the sensor is talking, what the sensor is saying, what the sensor is saying actually means. If I say 15, but if I don't know what 15 means, I cannot just upload it onto the cloud and think that it's going to work. So at the basis, the foundation is the Common Language Dictionary. Right, I think we've talked about a lot of things here. I would like to close off with a final question. In a current world which is full of misunderstandings, of many micro languages, even when you're actually talking the same mother tongue, maybe in this word we have been able to pull down a Babel Tower so that everybody in this word is really going to talk the same language. So, but at the end of the day, without woodworking made easy, some companies will be cut out of the market. Is this going to be a competitive advantage? So we'll end up at a point where without woodworking made easy, you don't go anywhere in this word, in the woodworking industry. Well, I like to emphasize the concept that this operation work was not done to cut out manufacturers from the market. That could be from Europe, from the US, from anywhere. On the contrary, our expectation is that when they will understand better the benefits that their clients, everybody's clients, can draw from this, that for sure we are going to have many more manufacturers joining this initiative. Of course, it's a standard. We have to start from somewhere, and you always, we started. We Europeans started, but we certainly expect. Actually, as I said, we already have some requests from non-EU manufacturers, and so our expectation is that sooner or later other companies will join the project. Good. Thank you. Thank you for your time. Thanks a lot to all the 7 cousins involved in woodworking made easy. There is a topic that everybody working with communication, fairgrounds, and all companies will sure look at this in more depth over the next few months. Thank you. Thank you, Gianluca Fariselli. Thank you, Antonio.